This is Mr. Coker with Geometry Lesson 4.1, the Pythagorean Theorem. The Pythagorean Theorem is a formula to find a missing side of a right triangle. So, I've got these two examples. Before I go through them, I just want to mention what the formula is. It's often written as a squared plus b squared equals c squared. I've written it as leg 1 squared plus leg 2 squared equals hypotenuse squared. And I'll show you why I like to put it that way in a minute. It's mostly because of the hypotenuse. So, we're talking about right triangles. Each right triangle, we have the right angle. It's a 90-degree angle that makes it a right triangle. And that's going to be marked for you, so you know what the right angle is. And then the three sides of a right triangle are the two legs and the hypotenuse. The legs are the two sides that are coming out of the right angle. They're connected to the right angle. For instance, here's the right angle, and the two sides that are connected to it are the legs. The side not touching the right angle, that's across or opposite the right angle, and which is also the longest side, that is the hypotenuse. If we take one leg and we take its length and we square that length, and then we add the other leg and we square that, we'll get the hypotenuse's length squared. Hopefully that makes sense. But I think it'll make sense in a minute. It's pretty easy to do though. I'm going to start with this example and then I've got another one. So I like to look at this in two ways. I'm going to give it in the most simple way that I can, the most simple description of how to do it. So always when we're talking about the Pythagorean Theorem, we're talking about, we're always squaring all of our sides. So I'm going to start by looking at what we have. Well, first thing I always want to do is label hypotenuse. So again, the side not touching the right angle, that's opposite the right angle, that is our hypotenuse. I always favor labeling that. And then I want to know, what side are we missing? What are we solving for? What are we trying to find? In this case, we have the two legs. We don't have the hypotenuse. When you are missing the hypotenuse, you're trying to find the hypotenuse, you're going to take one leg and square it, plus the other leg and square it, and you'll find the square of your hypotenuse. When you don't have the hypotenuse, you're adding. Now, this math is pretty easy. 3 squared plus 4 squared is the same as 9 plus 16. 3 squared is 9, 4 squared is 16. I'm not even writing that down. And the reason is, I always suggest to students, just put this in a calculator. Put the length, I should say, the length squared plus length squared in a calculator and hit enter. There is a practical reason. In this case, the math is pretty easy. But what if we had like 1.1, or we had something like 2.7, so just something like that? You might think, well, okay, you can still do the math, and you can, but it's more difficult. So I prefer putting in the calculator 3 squared plus 4 squared. You put that in a calculator, it will give you 25. Now 25 is not the answer, because remember, 25 is the square. So we take the number we got, we find the square root of that number, Square root of 25 is 5, so the answer is 5. Leg squared plus leg squared, find our answer, then find the square root of that number, and that is your length. So x equals 5. Now the second triangle, now if you're looking, you'll see that it's the same length. You'll know what x is because you can see the 3 and the 5 labeled. Okay. I'm going to describe now first of all, let's label the hypotenuse. Again, the hypotenuse is the side opposite the right angle. Of course it's 5. We know it is because it was on the other one too. Here we have the hypotenuse. When we have the hypotenuse, we're subtracting. What we're really doing is setting up and solving an equation, but we just wind up subtracting. I'll always like to tell students, if you're trying to find the hypotenuse, you add. If you are trying to find a leg, namely if you have the hypotenuse and you're trying to find a leg, you subtract. Take the hypotenuse, which is 5, so I'm going to do 5 squared, and I'm going to subtract 3 squared, the leg. Again, you can do this math in your head. You could easily do it. Just like as a rule, like as a habit, you put 5 squared minus 3 squared in a calculator. It will, of course, give you 16. Get your 16. Now you find the square. This is going to be this side squared. We're going to undo the square by doing a square root. Square root of 16. Of course, that's 4. And on this one, we get x equals 4. Well, we know it's going to be 4 because we had the first. We had the first of our examples. Anyway, I think the most simple right triangle you can find, the 3, 4, 5 right triangle, just to make for the examples to be easier to comprehend numbers. But I do want to make clear that it does not matter at all. It does not matter how complicated the numbers are. If you have numbers with the radicals or you have numbers with decimals, I'm assuming you have access to a calculator when you're doing this. If you do have access to a calculator, if you're missing the hypotenuse, you're solving for the hypotenuse, you're trying to find the hypotenuse, you add one side squared plus the other side squared, get your answer, find the square root of that number, of that answer, and that's it. That's your hypotenuse length. If you are given the hypotenuse, so you're trying to find a leg, you're solving for a leg, now you're going to start with the hypotenuse squared minus the leg squared, get your answer, find the square root of the answer, and that will be the length of the leg. So that's a Pythagorean theorem. The next video for geometry that I'll make will be about using the Pythagorean theorem to find out whether something is obtuse or acute. It's a little bit more complicated than this, but it's the same principle. Anyway, Pythagorean theorem is overall pretty easy as long as you know the rules and you get practice. So, thanks for watching.